Hey guys, welcome back to the channel. In this video, I'll be covering the rest of the concepts that we need for linear equations and also setting you guys up for the next topic. So let's just hop right into it. Don't forget to subscribe to the channel and leave a like button and comment down below any topics you guys want to see. But let's hop right into this. Okay, so we left off by defining the linear equation. So I defined the linear equation as a polynomial. Okay. As a polynomial of degree 1. So meaning it has a power of 1 of x. So this is linear equation. And the slope-intercept form, y is equal to mx plus b. Okay. Whereas b is the slope-intercept, and m is the slope. Okay. So essentially, the whole so with the linear equation, it's just a straight line, and the parent function we also said it goes straight through the origin. Sorry about that, guys. It goes straight to the origin with at a 45-degree angle. So that angle here is 45 degrees. Okay. All right. So in the actual equation, and the equation of the line is y is equal to x. F of x is equal to x. Okay. So we got that. Grab a new sheet of paper. Okay. So let's move on. So with that being said, we're going to look at transformations. And so before we hop into transformations, there's two other equations on line which we'll go in deeper into in a deeper video, in a separate video. We have this point slip form. Which is y minus y1 is equal to m times x minus x1. This is a really important formula right here for calculus, and we'll explain it in a separate video. And we also have standard form. Ax plus by is equal to c. Both of these are really standard. So this is a polynomial form. And that's how we derive the point slip form from it. We'll cover both of those in a separate video, but so those are two separate equations of a line. All right. So what if we have transformations, right? So we know the equation is y is equal to mx plus b. Okay. So m affects the steepness. Okay, so what if m is greater than 0? Okay, so what if it's greater than 1, not 0? What if it's greater than 1? Because if m is 0, it's a horizontal line. All right, so it just gets steeper. And I'll show this to you guys with y is equal to 2x. Okay, the easiest way to do this is, if you guys are given an equation, is just to plug in points. So let's do -1, 0, 1, and 2. -1 is -2, 0, 1, and 4, or 2 and 4. So -1, 1, 2, -2. Sorry, my bad, mistake there. That's -2, that's 0, 0, that's 1, 2, that's 2, 4. And we just draw the line. You guys there? It's best off if you guys have a ruler with you guys. I don't have one with me right now, but it's easy enough if it makes it easier just to show it's a straight line. And we just connect the points. And you can see there, compared to this, it's a steeper. So the greater so compared to this line, it's steeper. So this is steeper. Okay. So we could conclude that if f is if m is greater than 1, and the bigger m gets, the steeper the graph. Line, the graph of the line gets. Sorry guys. Sorry guys, I'm still getting over. I still have this wicked cough, but it is what it is, honestly, guys. Let's grab a new Sharpie. Sorry about that, guys. Okay, so now, what if m is 0? I said this earlier in the video. So if m is directly equal to 0, so if m is equal to 0, we know it's a horizontal line. So anything with y is equal to 3, like y is equal to 3, so y is equal to any constant, there is no slope at all. Y is equal to 0x plus b. It's just the y-intercept. It goes through the y-intercept, meaning there's no slope. I mean, so the easiest way to think about this is walk up a staircase. Well, there's no staircase here. It's just a plank. It's like you're walking on the floor. Versus any other line, you have to step and step and step. Now, what if we have and so you guys might be saying, oh, this isn't a function, but it's passed the vertical line test, as you guys see. So then we also have sorry guys. We also have what if y is equal to m. What if m is negative? What if m is less than 0? Well, if you guys remember from a previous video, the transformation of graphs, f of x. So if f of x is negative, it flips. It reflects across the x-axis. Whereas if f with negative x, f of negative x reflects across y. Sorry guys. All right, so like, give an example. So y is equal to negative. So y is equal to negative x. That's the easiest way to figure it out. So this is pretty much, so y is equal to mx plus b. This m, so it's y is equal to negative 1 times x plus 0 as our y-intercept. So it's going to pass through the origin, and we're multiplying our values by negative 1. So when it's 1, it's negative 1. When it's negative 1, it's 1. Draw a line straight through. So see there, it reflects, sorry, I got these backwards. It reflects across the y-axis. Or no, wait. No, x-axis, sorry about that, guys. It just reflects. Sorry, I wrote that wrong in my script, and all right. So we covered a slope. Now, what if we have now what about the intercepts? You guys are probably thinking. So, what if b is greater than 0? It moves up. So if you guys compared to the original function, the parent function. Okay. It moves up. So if b is greater than 0, it just moves up. Okay. It moves up. So it moves up. Graph. Now, if it's if the intercept is negative, so if sorry guys, if b is less than 0, well, it passes through, so it moves down, pretty much, as you guys see. Moves down. Okay, so and for this function, it's the only function. So for linear functions, it doesn't move left or right. It just moves up or down, and it just slopes to the left or to the right based off of positive or negative values. So, and you guys can put it together. So just put it all together. Y is equal to, so an example of it all together. So put it all together now. All right. We have the equation y is equal to 3x plus 2. Okay? Okay, so let's get a sheet of paper. So I need to draw us the coordinate axes. Sorry about that, guys. I know I need to get a new stand, but I'm really bad at this right now. I'm getting better. So let's rewrite the equation. Y is equal to 3x plus 2. So, okay. So we know the y-intercept is 2. So b is equal to 2. So it moves up 2 units. Okay. So then, so instead of plugging in points, you guys could always just, if it's in point slope or slope intercept form, pretty much we can look at this, the intercept and the slope. So the slope, if you remember, is rise over run. So this 3 is the same as 3 over 1. And so we rise 3 go over 1. So from 2 we go to 5. 1, 2, 3. And up 1. So 5 and up 1. And we can also go down, and that's enough, but the more points you have, the more accurate the graph is. I feel comfortable with 3 typically. So we could always go down 3 and to the left 1. It still gives us the value of 3. So 1, 2, 3, to the left 1. I'm sorry guys, that looks horrible. Next time when I do these, I'll bring rulers from now on. But that's how linear functions behave. I'll do more examples of this in future videos, but just to wrap it up, the idea of a linear function leads us into polynomials, and this idea of slope, slope and intercepts, and these other equations for lines are really important for calculus because it tells us to find the slope of the tangent line, and it's important for physics and any other math classes, any other math-related science courses, just because it allows us to derive the derivative and find the average rate of change, also in calculus the instantaneous rate of change. So just to recap of the video, so linear functions are 1 degree polynomials. And in the slope-intercept form, which is the form we usually graph lines in, y is equal to mx plus b. Its parent function is y is equal to x, and it goes straight to the origin. We have two other equations of the line, point slope form and its standard form. Which I'll cover those in other in upcoming videos. Then we also have different types of lines based off a slope. If the slope is positive, it goes upwards. It slants. It gets steeper. If the slope is negative, sorry about that, guys. It slopes backward. It reflects. If the slope is equal to 0, it's a horizontal line. If our intercepts are greater than 0, it shifts up. If it's lower than 0, it shifts down. I'll see you guys next video.